Welcome to today's webcast. We're going to go over SQL Diagnostic Manager and look at key benefits, core features, alerting, reporting, drill down, all that kind of good stuff. Hopefully you guys can hear me. There's a question and answer section within GoToWebinar where you guys can type questions to me. If one of you don't mind maybe writing that the audio and the video is working well, that helps me out. I'm the only one from IDERA on the call today, so I don't have anybody checking on that for me. I would appreciate it. There's quite a bit to cover. Oh, thank you very much. I appreciate that. There's quite a bit to cover, so we're going to go ahead and get started. SQL Diagnostic Manager is a very mature product. It's been in the marketplace for over 15 years now. We average right around 3 releases a year. So again, very mature, built from the ground up to monitor Microsoft SQL Server environments. And it's really able to cover just about any SQL Server out there, right? So if it's on-prem, cloud-based through Azure or AWS, running on Linux, Express, Developer, Enterprise Standard, SQL 2000, SQL 2019, frankly, to us, it doesn't really matter. We have functionality really for all those different environments. And the goal is to give you guys comprehensive understanding of how your SQL server is behaving. So we're doing comprehensive monitoring, looking at everything from operating system metrics into the SQL server, pulling back big picture information like job and backup information, as well as getting into the really detailed views of, individual weight statistics and, poor performing queries, deadlocks, blocks, those sorts of things. So again, it's really trying to give you a really deep insight into how your SQL servers are behaving. All that information that we gather is stored in a repository, and that repository gives us not only live data, obviously we have that ability, but we can also look at the past, and the past can be done a couple of different ways, right? So if I'm looking at history, reporting obviously comes into play, but I also have a feature in the tool called History Browser that lets me roll back the clock almost like a DVR, where I'm able to, drill in and understand, what the server is doing at 3:32 in the morning 3 weeks ago, as if it was live data, but in reality, I'm looking at the past. So that's a big part of what we'll look at today, how that works. But there's kind of a third way that I can leverage history, and that is for alerting. We have customers that are monitoring many hundreds and hundreds of SQL servers. And if you have to go in and tune your alert thresholds on a couple hundred SQL servers, because every SQL environment is relatively unique, right? The alert thresholds aren't going to be perfect out of the box, so you're going to have to tune some of that stuff. And we know how these servers have behaved. We know how the individual metrics related to those individual servers have behaved historically, and we can use those historical data sets to better understand where to set alert thresholds as well. So there's quite a bit of history in this product, and it really does help give you a real robust visualization as well as drill down into past performance. Now, alerting is another thing that we'll get into. Not only the the configuration of alerts, why is this thing red, why is it yellow, but once those things do change into a critical or warning state, what am I going to do about it? There's a number of different ways that alerts can be triggered. There's notification alerting through email, event log, SNMP trap. There's even direct SCOM integration for guys who are running SCOM. But there's also the ability to run scripts. As an example, I can run a T-SQL script in response to an alert. I can run a PowerShell command. I can run a SQL agent job. I can run a command line script. And the goal there is to not only notify you, hey, this is a problem right now, but potentially remediate some issues around that automatically without you guys having to jump into the product and deal with it. So, we'll get into alerting, we'll finish up with reporting, but, the goal of the call today is really to help you guys get a better understanding of what this tool is all about. Now, we're looking at version 11. Version 11 is not that old. I think it's been out for about a month now. There is a new release coming short, hopefully in the next, 3 to 4 weeks, version 11.1 that has some new functionality in it, but also has some kind of new features around old subjects like AWS, for example. Now, I'm not going to spend a lot of time in PowerPoint. Let me switch over to one more slide we'll look at architecture, then we'll actually jump into the product. The architecture of this tool is really simple. We don't install anything on the SQL servers that are being monitored. Everything is done remotely. So getting it up and running is pretty easy, right? So if you want to do a trial or if you're going to purchase the product, etc., you can reach out to the IDERA website, download the installer from us directly. If you're doing a trial, by the way, the initial download will come with a predefined key, a predefined trial key that's good for 15 instances for 2 weeks. So out of the box, you get 2 weeks to do whatever you want with the tool. It's full functioning. It's a pretty simple install. So whatever machine that you run the installer on, I would consider the DM server, right? It's Diagnostic Manager server. And what's going to happen is on that box, we'll install a set of Windows services. There's two main services that make up the back end of Diagnostic Manager, the SQL DM collection service and the SQL DM management service. Now, the collection service really does what it says, right? It's the piece that's reaching out, pulling the WMI metrics, pulling the SQL metrics, pulling the DMVs, extended events, etc. Once that data has been picked up, it hands it to the management service. The management service parses through all that information. It's making determinations around alerting. So if it sees something it doesn't like, it sends out the script, the email runs the script of the job for you. And then ultimately, the management service is kind of the broker of communication, storing the data, feeding the data out to the end user interfaces as well. The repository, when you're walking through the installer, it's going to ask you what server, SQL server, do you want to install the repository on. You can certainly have it on the same machine as the DM services. Generally speaking, if you're going to monitor more than 100 instances at a time, we do start recommending around that number that you have a separate server hosting the DM repository than the services, so they don't compete for resources. It keeps things quick and nimble. But if you're under that 100 instance number, frankly, you can put it anywhere you want. Generally speaking, the repository is going to grow right around 2 to 3 gigs per instance per year. So if you're going to monitor, 10 SQL servers, you should probably plan for 20 to 30 gigs worth of data. Now, we do groom that data every night. There's an agent job that you can schedule within the console, so you don't have to go out and edit your jobs. But there's a job that will kick off at 3 a.m. nightly by default, and it will clear data out of the repository, history out of the repository based on different date ranges. So the really detailed stuff, looking at like individual sessions, queries, deadlocks, wait statistics, blocking events, and our history browser data gets groomed at 31 days. That's most of the information that we're collecting. So you have a really, really detailed month's worth of data to play with. And then above that would be, resource utilization, transactions per second, log fullness and things like that we keep for a year. And then growth rates, this database and table growth rates are kept for 3 years. And the reason for that 3 years is so that you can get better forecasting around data growth in the future. So the more data you have to work with, the more accurate those forecasts are going to be. But again, if you leave the defaults in place, and I'll show you this stuff in a little bit when we get to the tool, if you leave the defaults in place, you're probably looking at 2 to 3 gigs per instance per year. And the repository is supported on 2015 and above, standard developer and enterprise. We do not support, and you may have kind of caught this already, but we don't support Express for the repository because we need jobs to do things for us, and Express doesn't have jobs, right? Also, you'll probably run out of space as far as what Express supports eventually. So standard developer enterprise 2015 or above can be the repository location. Again, from a monitoring standpoint, we have support for Azure, AWS, on-prem, virtualization, which I haven't mentioned yet. We do have monitoring available if you want to. It's included with the product. VMware monitoring as well as Hyper-V monitoring. Now, this is not a VMware or Hyper-V monitoring tool. The idea is that we can pull in some metrics around that technology on the back end to help you understand if there's anything critical happening from a VM perspective. And then Express Standard Developer Enterprise, SQL 2000 to 2019. Now, as far as UI goes, right, there's a couple of different ways that you can get into the data that we've collected. The general idea is that this is a desktop client or a fact client based application, meaning that there's a .NET console that you would install on your workstation. It would remotely connect over to wherever your DM application is installed, and we will feed you information to your laptop, your desktop. There are web consoles that are also available. That being said, they're not as feature rich and function rich as what you can do in the desktop client. So I think of it more of a secondary user interface, but certainly there are web consoles available. And then you also have the ability through reporting to run through SSRS. So you don't have to run all the reports in the desktop client. You have the option, if you would like, to leverage SSRS, and that gives you a couple benefits. A, if you just need to build a report, you can hit a URL and go build it. But B, because there's subscriptions and extra features in SSRS, like automation through subscriptions, being able to go in there and edit and rebrand, etc., it does add in some neat functionality that can save DBAs a lot of time, right? I say DBAs, it's not always that a DBA is going to be your main user, right? Sometimes, you don't have a DBA. And one of the really nice things about this tool is if you're not a database administrator, it can help you become a better one, right? So there's a lot of monitoring that we're doing. There's a lot of descriptions around the individual alertable metrics that we're pulling back. And there's about 105 unique metrics that we monitor per instance, meaning that I may not even know what this alert is, but because there's help articles around those metrics, let me show you what I mean, right? So if I'm looking at a whole bunch of SQL servers and I see some alerts, these aren't the most exciting, but I can say show alert help, for example, on a PLE alert, and it's going to tell me a little bit about what PLE is. And, if I need more, I can go Google it and get other resources around it. But the good news is that we kind of know what to look for. Therefore, if we see something that doesn't look right, we can help you understand, hey, there's a problem here that you may want to address. But if you are a seasoned DBA, there's a ton of really good DBA type information in here that you can work with to identify root cause and really drill down and understand both in real time and historically what's happening on the back end of the SQL server. My environment's not huge. I'm monitoring 10 instances of SQL. The view that we're in right now is just an all servers view, but be aware that you can control and make your own kind of organization within the tool. We use a model called tagging, where we can organize instances together into logical groups. What I mean by that is, if I look at my Austin group, that's where I'm located, right? There's a handful of SQL servers in Austin. Some of these are dev servers, some of these are prod servers. I have a dev group. Well, guess what? Those dev servers are there. I have a prod group. Guess what? Those prod servers are there. Meaning that you can organize these servers together into different views, but those views are available throughout the tool and leveraged against different features. What I mean by that is if I take a alert threshold and change what my PLE alert levels may be, I can change it on server A and then apply it to a group, so I don't have to change it 10 times more, right? Or if I'm setting up a feature called application security where I'm controlling who can view what, I can do that towards a group, or alert responses, alert configuration, obviously, custom counters, maintenance mode. There's lots of things you can do directed towards groups. Maintenance mode, for example, this server here that's all grayed out, it's in maintenance mode, meaning I'm not monitoring it right now. And you can schedule that individually, instance per instance, or you can set it up per group. That's a nice function. And then the individual instances themselves is really where you start getting the data back, right? So there's different views you can go to, but once we kind of understand this is the server we want to deal with, you select that box from the list and you start getting, sessions, queries, resources, database, service, log, analyze, right? So there's a bunch of subcategories of data, drilling into the individual SPIDs, maybe going look at weight statistics, or getting into the resources, right? There's a lot of information now available for me around this particular SQL Server instance. So how does this data get into the tool? What type of data is it? How is it being monitored? If you break down and look at the properties of an individual instance, most of the monitoring most of the data, let me rephrase that, most of the information that we're looking at within this tool is broken down by minute. All right, for the prod 1 server, I'm doing my data collection once a minute. So if we're looking at these charts behind here, these are basically 1-minute charts, right? It's matching up with this polling interval. Another little side note, telling us what type of SQL server is it. This is an on-prem Windows server. We can put it in different groups, and then our main polling interval. So the idea is that we're doing a snapshot. We're collecting a bunch of performance data basically through WMI calls and a batch of a couple different queries against the SQL server every minute. That information is then stored in a repository. So it's a slice of time, minute by minute. Now, 1 minute is a long time in SQL Server, so there are some things that are happening between those polling intervals that I'm going to be concerned about. For example, activity monitor is going to help backfill around deadlock, autogrowth, and blocking. We generally use extended events for this type of data collection, meaning that it's persistent. It doesn't matter if I have a 10 millisecond deadlock and my polling interval is 10 minutes, we'll still know about every deadlock because we're collecting it differently, right? Similarly, Query Monitor. Now, Query Monitor actually has a couple of different ways that we can gather poor performing queries. I personally use Query Store. I have it enabled on the SQL Server instance, meaning that the Diagnostic tool is just going to query the Query Store information and bring that into Diagnostic, so DM isn't actually collecting any poor performing queries. In my case, it's just gathering it from known information in the SQL Server instance. But if you don't use Query Store, and by the way, side note, Diagnostic never enables Query Store. Diagnostic can leverage it, but it doesn't turn it on. So if you're not using it, it's not enabled, or you don't have, you're not on new versions of SQL, 16 and above, you can use extended events for that data collection. And that goes all the way up to 19, right? So anything from 2008 to 2019, you can run your query gathering through extended events. But the point, I guess, of this is to calculate and understand and view your poor performing SQL statements. Now, I say statements, that's batches, stored procedures, triggers as well. What does that mean to you, though? Every environment, your workloads are different, et cetera. So maybe server A, that's a high CPU count and high time count. On this server, I'm just looking at time, right? So you can put in the values that you think are where your poor performers are so that we're showing you exactly what you need to see. I've just said anything over 2 seconds I want to know about. So this, again, will help kind of backfill that 1 minute polling interval. And then there's a third advanced configuration around monitoring, and this is really important data to have at your fingertips, which is weight data. Right, so detailed weight data, being able to break down a weight statistic by session, user, application, host, statement, et cetera. This is not done by default 24/7. It's really done in real time only. And part of the reason why we do that is to preserve space in the DM repository. It's not very expensive to collect, but if you're collecting really detailed weights on a bunch of servers all the time, it's going to be, I wouldn't say expensive, but there's going to be more data growth there. So you have the option if you want to do what I'm doing, which is collecting indefinitely. Some servers, production servers, I always collect indefinitely. Dev servers, it kind of depends on what they're doing, right? Sometimes if I'm doing a lot of testing in there, A/B testing, things like that, I do want to have that enabled. Otherwise, maybe I don't turn it on. It's really up to you, I guess, is the takeaway. But one thing that I do point out for new users, generally speaking, I don't use extended events, and generally speaking, I do not use Query Store to gather weight data. So if you notice these two boxes are unchecked at the bottom, the idea is that I'm really relying on dynamic management views to fill in that weight data. And DMVs do a great job. There's really not a need for extended events or Query Store monitoring to understand weight information. So that's the way I recommend, and generally we recommend that you use it. So not to get too deep in the weeds, but the idea is that every instance can be configured a little bit differently, and based on that configuration is essentially what we're going to see here, right? So the information on this screen right now is live. If you notice up here, it says real time, and then it has the time frame, right, the day. So live information about the SQL Server. It doesn't really matter which view, assuming I'm on live. If I drop over to resources, this is live resources. You can see I rebooted right before the call. Sessions, right? So what sessions are out there? I want to get into the session details. So these are active sessions. Maybe not active per se, but these are the sessions. If I ran an SP-Who2, this is basically what I would see, right? So there's lots of live data in here. The problem is, as a DBA, looking at the live view of the SQL Server isn't always exactly what I need to see. I might need to figure out what happened last week or what happened 30 minutes ago. So one of the nice things that you can do in here, there's a couple ways you can do this. Let me drop over to a chart view. So if I'm looking at this chart, it's basically 1 hour. Why is it 1 hour? Well, because that's how I have it defined. Maybe I want to look at 6 hours, right? So I can drop back, look at more time. I can go back pretty far. I can go out 5 days, 24 hours. The reason why I might be doing this is I don't know what I'm looking for, right? Someone might call and complain about a performance problem that happened yesterday, but I don't know anything other than they're mad at me because something was running slow yesterday. So if I back these charts out and look at 24 hours, I can kind of see in here some interesting things, right? So this, for example, this cluster of weights right here is very different than everything else we saw in the day. There's one right there. There's a couple, right? So by stepping back, it can give me an idea of where to go into the detail. And one of the cool things about this is I can just highlight over the section of time that I'm interested in, and guess what? It drilled me into that narrow window of time but gave me more detail. So the idea of extending out the time, I generally, by the way, look at 1 hour's worth of data. So extending out the time, drilling into the time period that you're interested in is one way to approach history. Another way, generally it's because you kind of know what time you're looking at, is directly through the history browser. So if someone picked up the phone and said, hey, you know, at 3:30 yesterday we had an issue, or at 3:30 on Monday or Friday or whatever we had an issue, you can then pick the day. So let's go back to the 12th, and then down below here, you know, maybe I want to go look at 6:32 a.m. Well, guess what? On the 12th and today, so to go back to live view, you can just click right there. And today, we're actually at 10 o'clock versus 6 a.m. We see similar workloads, right? So there's a block basically that's happening on both those days that maybe I want to get into. What statement was it? Right, so if I click on the statement view, I can pull the statement out. So this select statement, you know, which application, which database, which client, which session, which user. Right, so there's different ways you can look at that. But again, I'm not looking at live. I'm looking at 5:12, 6:32 a.m. So history browser is directly accessible in that way. And the third way, which frankly I use probably the most, is through alerting. And what I mean by that is often I'll get an email or something like that there's a problem, but I don't have the luxury of really getting into it at that exact period of time. So if I know what I'm looking for, you know, right now we're looking at all active alerts, every alert that's kicked off right now in real time. But if I want to look at something in the past, often I'll filter it down. So I got an email earlier, maybe yesterday afternoon, about TempDB running low on space. So let's go back and see. Actually, that was earlier today. So about 7:20, 7:19 it started, 7:21 it was still there, 7:22 it ended. But there was an email that was talking about this stored procedure that was consuming about 3 gigs of TempDB space coming from this job, this user, this session, right? So the actual email I get is pretty informative, right? There's good information to play with. But because we're recording all this stuff in our repository, I can really drill down and understand this from different perspectives as well. So if I right-click on the alert, real time isn't going to give me any value. I want historical view. I select that. It's going to take me to the instance, prod 1. It's going to take me to database TempDB summary because that's the problem. And then it's going to show me charts and then give me tables of the data that was collected at 7:21 this morning when we saw that problem. And we saw that it had come in earlier, right? So there were 2 different alerts that came through. You can see this double spike right there in TempDB. 102 is the one that's consuming the resources right now, right? I can then drill into the details of 102, which happens to be this one on the top, right? We can see the command TempDB workout, execute store procedure, TempDB workout coming from this job. But now I even have more data, right? The resource utilization, so CPU. If you look at the CPU milliseconds column, this is a total CPU for the life of the session. So if the session logged in 3 weeks ago, it might have a really huge CPU number. But if you look at the delta, like this is an example here, right? So 332,000 milliseconds of CPU, but right now it's only using 171 milliseconds of CPU, right? So yes, this has used a lot of CPU over time, but this one is using all the CPU right now, right? And the same thing with IO, physical IO total, physical IO delta. So the delta on 102 is very high for CPU and IO. And what that basically means is maybe I didn't know to look at TempDB. Maybe what I saw was this increase, a double spike of CPU here. Well, we had that double spike of TempDB. Those two things are related. Or if I look at the disk, guess what's on my T drive? TempDB, right? So the T drive's getting really busy. It may be that I saw those two symptoms. I got alerted the CPU was high. I got alerted the disk activity was high. And from that, I could kind of glean, hey, maybe we are running out of TempDB, or maybe this is affecting TempDB because we can see that information here, right? So there's different ways to look at that. Another little side note, I don't always do this, but I will often go look at the server's active alerts at the time frame suggested, right? So we got the alert. Which one are you? Where are you? We got this alert, right? This is the one we filtered in, used to go back in time, and we saw that kind of in a vacuum. But if I look at the whole server at that same time frame, there were quite a few other alerts kicking off. The T and the D drive, probably CPU in here as well, right? So there was a number of different indicators that we were having an issue. It wasn't just that one single metric. They are all kind of tied in together. So the only thing I really don't know by looking at this is what it is about this stored proc that's causing me the problem, right? What is it in that stored procedure that caused all this growth? And one way to evaluate that, I think the best way that I like to do it is by looking at weights, right? So if I'm looking at the query weights for that time frame, guess what? There's a double spike in here, similar to what we saw in the TempDB growth, right? So we can see the weight type, CX packet, page IO latch, consumer weights, IO, right? So there's a number of different weights that are kind of pointing me in that parallelism TempDB area. Well, which sessions? We knew 102 was the culprit, right? So guess what? 102 is the pink, right? So all this pink stuff is 102. So meaning if I look at this from a statement perspective, I know that this is what was actually running in that stored procedure that was causing me that pain. Now this is a timeline view of weights. There's a drop down here that will change me to a duration view. So another way to have looked at that would have been, oh, well, we're getting 6 packet weights. Which statements are those coming from? Or, we know that it was session 102. What statements are we getting from 102? So there's a couple other, but the one that's actually painful is this guy, right? So this is out of the box. Well, it's always going to match whatever the time scale you have set here. So right now we're only looking at an hour. If I change that to 6 hours, well, the insert that we just looked at is still there, but it's number 2 on the list. The most expensive weight query was the select above it, right? So you can easily kind of get a high level and then drill down view from a weight. The other way, though, that I could, let me switch back over time. Another way that I could do this is by looking at just queries. So again, we have a feature in the tool called Query Monitor, and my definition was anything over 2 seconds in duration, meaning that when I look at this signature mode view, which is a little complicated, you'll not see anything in here below 2 seconds, right? So everything is kind of above that 2 second threshold. Now, I say it's a little bit complicated because what a signature mode really is looking at all the statements. So if I look at this view, which is just show me everything that exceeded 2 seconds, right? So there's no real organization here. I can go in and say, well, show me the longest, show me the shortest, the most reads, the most writes, whatever, right? So I can look at each individual query collected over whatever time frame that you've inputted, right? But if I'm looking at this from a signature mode, what we're doing is basically organizing that together for you based on the SQL statements that were collected. So a signature, in this case, that select statement that we saw earlier that had that top weight for the last 6 hours, That's this guy. Now, there's some things missing. It's not a select top hash, it's a select top 500. There's some hashes there, there's a hash here. So what we're doing is saying, oh, well, this statement looks like a signature. There may be some slight variations of that statement that have run throughout the day, but basically it's the same query. And the cool thing about doing that is it helps me understand that that statement was captured 19 different times over this time frame, with an average duration of 64 seconds, right? So if I'm looking to tune something or trying to understand some low-hanging fruit to improve, this is probably the one that I'm after because it has the longest average duration and it has the most frequent collection, right? I can then from there go drill into the query history and really see how it's been behaving historically. Now, interestingly, if you look at the duration here, sometimes it runs very long. Most of the other times it's kind of in that 7 to 4 second range. You can see that reflected here at the chart. CPU increase, duration increase. So those two things go together. When that CPU is increasing, it slows down quite a bit because there's other workloads on the system that are, it's complicated. But the idea is that maybe I need to fix the CPU on this guy. What's going on here? What's conflicting with it? There's different approaches that I could take, right? And one thing I might want to confirm, the reads are flat, right? So it's not because it's not taking longer because average CPU, where were you at? CPUs per second, right? So it's not taking longer because it's returning more data. It's taking longer because something else is happening. I'm going to cheat a little bit here just for the sake of time, but if you look at that statement, you can kind of see based on the weight type, intent shared, right? We can kind of tell that this was blocking. So I bet you if I go look at, the block view, guess what's being blocked, right? That statement's being blocked. So when blocking is happening directed towards this statement, it takes a lot longer to run, which is pretty obvious. But the cool thing, again, is I'm not looking at live data. We're all looking at information that's been collected historically. I'm working with it as if it was live, but I have that luxury of doing it later. So there's a lot of really cool ways to get in and visualize and understand how your SQL servers have behaved historically. I think one takeaway, though, is, excuse me, I have a bit of allergies today, so I'm sneezing, so I had to mute there for a second. One of the realities, though, is if you're monitoring lots and lots of SQL servers, you're not going to have the luxury of drilling into each one and trying to find these problems. So the tool's designed through alerting, kind of like what we did there. We identified a problem, we drilled into it, we looked at it from a bunch of different directions. The idea is the tool's really here to help you understand, hey, you're having a problem on this server, go look at that. You're having problems over here on this server, look at that. Or you're having a, enterprise-wide, everything is slowed down from a response time perspective, or this whole segment, network segment is down, we can't monitor it anymore, right? So there's a lot of detailed alerting that we can pull out of the tool to help you understand where to go. The issue with detailed alerting, and this is not an IDERA issue, this is an issue related to all kind of performance monitoring tools, is if your alert thresholds are not defined correctly, you can miss or ignore things that you really need to understand from an alert perspective. Now, I mentioned very early on that we have some features in the tool. So if I right-click on a server, configure alerts, we have some features in the tool that can help you define your alert thresholds quickly. Let me make these a little bit bigger. And really what I'm talking about, if I hover over this little bar at the top, it turns yellow. That's what I'm talking about. But before we go in there and look at that bar, let me group these together. And let me show you one of these guys individually. I saw this, this procedure cache hit ratio alert. We're getting a warning on it right now. So why are we getting a warning? Well, if you look at my warning threshold, it's 98 to 91. So if it's less than 98 and greater than 91, you're going to get a warning alert. If it's below 91, you're going to get a critical alert. This is an inverse metric for people who don't know, right? So the lower the procedure cache hit ratio, the worse off you are. The higher, the better you are. Now, what I'm really getting at is this little green box here. There's a feature called baselining. So we're measuring historically how this metric has behaved. We have 6,000 at the bottom there. You'll see 6,790. So we have 6,790 data collections to understand that my average has been 94.4, the standard deviation of 1.7. So if my average is 94.4 and my warning threshold is 98, I would think that this server is going to be yellow 24/7 because that's not realistic for how this server's behaved historically, right? So visually, it's giving me an idea that maybe I want to drag that down a little bit. So if it gets down to 93, which is a deviation from the norm, that's when I want the alert to trigger. There are about 100 plus, we'll just say that, 100 plus metrics in here to tweak and tune and play with. I don't want to visually have to do that on every single metric, much less do that on 500 SQL servers, right? So that's what the bar is doing for me. If I click on the bar, it said, hey, listen, I've gone through your metrics. It looks like page life expectancy. It looks like OS memory. Looks like logins per second, right? You'll see in here OS memory, for example, the average has been 82.7. My warning threshold is 75. That's not going to work. It wants me to change that to 85, 87. The one we just looked at, procedure cache hit ratio, right? We know it's 94. We check that box. It's reconfiguring to 91, 88. So instead of worrying about 105 metrics, I'm worrying about these 6, right? So I can go in here, tweak and tune those 6, and then clean up that server. It's going to turn green, assuming nothing bad's happening, and we can move forward. One little bit, though, this is math. So there's not like an AI, a machine learning engine on the back end that's literally going in there and tweaking and tuning these metrics for me. We're looking at how your metric has behaved historically, and then applying a filter of 2% above for warning and 5% for baseline, or above the baseline for critical. So if it says, oh, your average SQL Server CPU is 89 or 99%, we think you should set your threshold to 100%. That's probably not the best recommendation or for you to take. That's a takeaway that you need to go have more CPU, right? So it's math, but again, it gives you a short list to play with so you don't have to deal with everything. As far as the metrics themselves go, they're categorized. So backup alerting at the very top. Custom, we'll talk about this in a minute, but the idea of custom is there may be some things that I want to measure that nobody else cares about that aren't built into the tool. I can add them to what's called a custom counter. And then below that, database, right? So always on availability group, there's about 13 different alerts there. There's data file, file group, log file, mirroring, 10db, fragmentation, so quite a few different database-specific alerts. Database as a service, AWS, like RDS, and managed instance, database, platform as a service, database, SQL through Azure, some specific metrics in here. One little thing is low and high, so we're actually measuring or alerting if you're not using as much resources as you have allocated to that Azure database, for example. So it might give you some idea, hey, we can spend less, lower service tier on that guy. So there's some weird, or maybe not weird, some interesting alerts around platform as a service. Error log, agent log alerting. Primarily here, by the way, we're looking at severity levels, but every metric will have this advanced button. An example of advanced for error log would be, regular expressions or text that you want to parse out outside of the severity level, right? So even though it might be severity level 5, I still might want to be alerted if it has XYZ text in it, right? And let me back up a little bit. Every metric, again, has some little advanced feature, and the idea is to help you tune this stuff to get even more accurate. A different example would be something like this. For disk drive, space, log full percentages, any kind of space type alert, we're going to look at, the default is 75/90, meaning that if any transaction log is 75% full, that's warning. Any transaction log 90% full, that's critical. But there may be like this little one-off T-log on this database where I have a different threshold, right? So the reason why I'm using advanced is to fine-tune to my exact situation, and pretty much everything has some advanced feature. Error log stuff, operational states, which is kind of high-level configuration of the server, resource, CPU, memory, disk, all in here. Services, this is kind of a broad basket, but things like cluster failover, replication, Service availability, so is the server running or not? That's not really fair. SQL servers can be a lot of things. Running is really how we prefer them to be. So running is green, everything else is warning or critical, right? So service availability, but we're also looking at things like jobs. Are your jobs running long? And again, just kind of like a disk, you could say, well, that's generally how we think a job should run, but this job's a little different. Maybe we have a different threshold for that backup job, right? But you can do jobs running long based on percentage, meaning that we're looking at the past performance and then looking at the average runtime. If it's exceeding that by a certain percentage, that's when we want to be alerted. And then you also have that option to alert on minutes. So this job needs to be done in 6 minutes. If it's not done in 6 minutes, the world's going to fall apart, right? You can go in and set that threshold based on a minute value as well. And then there's also, I already mentioned it, replications in there as well. And then further down, you'll get into sessions, deadlocking, blocking session CPU, and then virtualization at the bottom. Virtualization monitoring is something that we can do. It's included in the product. It's no additional charge to do virtualization monitoring. It is an extra step to set up. We don't need any kind of administrative VMware rights or VMware rights specifically. Hyper-V, you need OS level permissions to gather the Hyper-V metrics from the host. But the way we do it for VMware, we're just talking to vCenter. And as you can see, it's not alerting on everything. There's, I think, 14 alerts, right? 4 of them are from the host level. The other 9 are from the virtual machine. But there are some good ones. For example, CPU ready wait time, right? So this is telling me how many milliseconds the virtual CPU is waiting for the physical CPU. That can really be a heavy indication of oversubscription, right? So you have 5 VMs on one host. One of them is stealing all the resources from the others. This would indicate that. So if you want to do VM monitoring, when I shut this window down, I'll show you how you set it up. But it can alert you in certain scenarios where VMware may be affecting the SQL Server's performance. Now, one other little note. If you look, there's this little icon was there. If we come up here, there's another icon there. If we come up further, there's an icon there. Those icons are there because we actually modified those metrics. And why that matters is if I hit the apply button, I kind of want to know what I'm applying. So we changed 3 different thresholds. Do I want to apply those 3 thresholds to other SQL servers, other tags, groups of SQL servers, or other templates? Yes. Please apply that on every server. Or no, let's apply that just to the production boxes. Or let's do production boxes and my test servers, right? So you can apply those 3 changes globally. You also have the ability to apply those changes to templates. Out of the box, there's critical only, performance, Azure, AWS. There's a bunch of out-of-the-box templates that you may want to modify. You can create your own. So I have my own little homegrown dev template. I have my own little homegrown prod template. But once the template's been created, I can always apply that to other servers. Again, I'm taking those 3 changes, applying it to an existing template. By the way, if you want to create your one little homegrown template, or your multiple homegrown templates, you can take an existing server and just say create template and take those settings, save them off, and you can use them later. Also, if you go under the tools menu, there is the alert configuration template screen where you can manage your existing templates, create your own from scratch. Let me show you real fast. This is not going to work because for me to hit vCenter, I have to be on a different machine, actually the machine that's running my DM collection service. So this is going to break, but the idea is, where is vCenter, right? You need a read account, not an admin account. And then once you've done that, you check the boxes, right? You check the boxes that are associated with this vCenter environment. You know what, for the sake of you guys' sanity and my own, let me show you it for real. So what we're pulling into right now is the server that's hosting Diagnostic. It's called SQL Dev 1, right? So this is where the SQL DM collection service is, right? SQL DM, sorry. That's not what I wanted to run. SQL DM collection service, SQL DM management service, right? So this is where the monitoring is coming from. On my laptop, which we've been looking at all day, it's connecting over to the DM repository on Dev1, right? So it's pulling from that virtual machine. Now, this virtual machine has VPN access to Houston, where that vCenter environment is. So if I go into VM configuration here, this will actually show up. So I have 5 virtual machines on VCO1. These are 2 of those 5 link. So once I've done that, if I go click into one of these virtual machines, and I can now go back to my actual workstation, because my workstation doesn't have to access Houston. VM is accessing Houston. Unfortunately, there's not a lot of load on this, but you can kind of see. Switch over to VM. So the VM, virtual machine memory, host memory, right? So the virtual machine has very low memory utilization. The host is only 50% as well. CPU, I was trying to, here we go. So, well, I say that there's not a lot, but you can see the green and the blue here, right? So the SQL Server is the green, is the blue, the total OS is the green, the gold is the virtual machine CPU, the pink is the host CPU. So if I saw the pink way up here at the top, that's an indication, hey, we have a problem. We may also have, let me clear out this filter. Let me see if I have any of those alerts around VMware. Oh, I do. So that one metric I was just talking about, virtual CPU ready wait time. So my virtual CPU is waiting 380 milliseconds to get access to the physical CPU on ESX15. All right, so that tie-in can help out in a lot of ways if you're running into virtualization issues causing performance problems. So that's kind of the first step in the alert process. Look at questions. One second. I think there was a few questions that popped up. Okay. Yeah, one of the questions is about recording. So yeah, this is all recorded. It should be recorded. And let me double check on that. It should auto record. It is. So as soon as this is over, it takes some time to process them, but we'll send out a link to all the attendees and you can download it for sure. So what we've talked about really was kind of looking at the past, how we drill down, how we adjust time, how the data is being gathered. Frankly, the way I use the tool quite a bit is letting the alerts kind of drive me into where I need to go, right? So we wanted to figure out where to set these alert thresholds. And once we've set the alert thresholds, what am I going to do with it, right? Let me pull up an example real fast. One second. Sorry, my server fans just turned on real loud. I had to adjust for that. So let me give you a real example before we get in to show you alert responses. Let's look at this one. This one will work. Block session wait time. A couple of days worth of data. So we're getting those blocks. We saw that earlier, right? So when that select statement runs really long, we know that blocking is causing that issue. And if we look at like this guy here, that's not the exact example, but that'll work. That's fine. Okay, so what I'm getting at is this. I know that's so alert actions and responses. So once an alert is raised, so you'll see these alerts in the tool, right? Raised, lowered, raised, lowered. So raised to critical means it's a brand new incident. It was previously fine, now it's critical. Raised to critical. Lowered, it was a problem, now it's not, right? There's also, and I might have one, let me come back in here, remained. Generally, I don't have a lot of those. Yeah, there aren't, but remained, so the server, the blocking may last for like 5 minutes. So every time we go monitor, it's still blocking. Oh, remain critical, remain critical, remain critical, etc. Right? Interestingly, I don't have that in my environment because I'm cheating quite a bit on the alert response side. What I mean by that is there's different ways that we can respond to an alert is raised. So when I see something as critical from a blocking perspective, meaning that blocking is lasting longer than 90 seconds, what am I going to do about it? Well, in my case, I'm doing a couple different things. I'm using the email provider to send out an email. I'm also writing the event log because I want to know via a different application. We use a product called Uptime that does event log scraping, so it's picking up there. I'm also running a T-SQL script that kills the lead blocker, right? So there's a number of different things that we can do in a PowerShell command to pop up a alert box on my screen to know that that happened. So you can do a lot of different things with these alert responses to help fix problems as well as notify. And the way these rules set up is very much like a rule in Outlook. So I call this kill blocking prod. Most people would never do this, but this is just a kind of crazy example of what is possible. Right, so at the top you define your conditions, the middle are your actions, the bottom is the rule. And essentially what I've said is if any of my production servers, which I have 5, have the metric block session wait time showing up as critical, which is again 90 seconds over, do 4 things. Send David an email, write to the Windows event log, kill the lead blocker, and pop up an alert box through PowerShell. So you add essentially what response you want to do, and then inside the response or the action, you'll notice variables in here, right? So a SQL DM alert, variable summary, severity, instance. So we're grabbing variables from the alert text and plugging them in where you want them to be. The event log entry is straightforward. The T-SQL that I'm running, again, will rely on variables. I'm using the instance name variable to figure out which of the 5 SQL servers to run this script on. So basically I'm looking at, it's hidden over here, but instance is in the alert, but it's right behind me. And then I'm also pulling in the alert summary string, which is session 75 blocking for, and then I'm parsing that to get the SPID and having it killed, right? And then there's a PowerShell script that runs after the fact that tells me that that just happened as kind of an alert box on my screen. The point being that these alerts can be very simple. If something is critical, send me an email. But you can get really descriptive and really laser focused on certain areas, meaning that you can do a lot of remediation with it if you need to. We're running a little bit low on time. If you guys have questions, please start typing those in. In the meantime, I'm going to talk about the last core area of the tool, which is really reporting. I think before we go there, though, let me talk a little bit about custom counters because that comes into play. The idea of a custom counter is, again, if there's something that you want to measure that we don't do out of the box, you can generally add it. And the reason why this ties into reporting is if there's some unique metric that you just thrown in the tool that we don't know about, obviously there's not going to be a report there. So we can build a custom report around a custom metric if that's what you want to do. But there's different categories of custom counter. Windows counter, which literally are any WMI or perf1 counter. These are wizard driven. So if I say WMI counter, I go look at, I pick a server. This is just really a sample server, for example, meaning that I can build this metric using dev2 as my sample server and then apply it to any number of other instances. You don't have to do it for each server. But these basically are all the different WMI counters. Some of them obviously SQL related. Some of them are related to my printer, right? But the point is anything that you really want to look at, you can build in. WMI perf1 SQL Server counter, if you can write a T-SQL script that returns a numeric value, there's, 185 or so VMware counters that I can look at. ESX disk, for example, I want to look at the usage, or I want to look at the write rate on this LUN, right? So you can get really detailed. The point being, again, if it's something that we don't measure, you want to measure, we can measure it. You can then link it to groups. You can link it to individual servers. And once that's done, you can alert and report and view it just like any other metric. The problem, though, from a reports perspective is if you build that custom metric, we don't know about it. Therefore, you'll have to go under reports, custom, new, and pick off the metrics that you want. Obviously, the idea might be that you want to pick up some of these custom counters, right? Maybe mix in some virtualization counters with it, and then mix in some SQL Server counters and operating system, whatever, right? So there's that ability to kind of drive and design your own report. It doesn't have to be because you have a custom counter. It can be for any purpose, really, but it's pretty easy to do. Let me check on questions real fast. All right. So the only other little kind of thing to think about from a report perspective is there's kind of three different types of reports. Generally speaking, everything can be deployed to SSRS with the exception of forecast reports. Disk database table forecasting use algorithms, linear and or exponential algorithm to predict the future. Let me give you a real world example. If I go look at the SQL DM repository, and I can do multi-select here. I'm going to just do one database. So we'll just do the DM repository database. We'll go back to a custom time frame of November 1st of 2020. So we'll go back to November of last year until today, and then we'll use that to predict out 90 days into the future. We want to see free space, and we're going to do a linear forecast. So what this is really doing is looking at a daily growth rate of this database as of November till today. And that's what we're seeing in this view. So the green is November 1st. The end of the green here is today. Now, I'm using a linear algorithm to predict based on the green, the blue, which is 90 days into the future. So August 1st, we're going to be about 17 gigs, 16 gigs. And then the dotted line up here is the free space available. So I'm going to be at 16 gigs in August. I'm out of space at 20 gigs. Based in November, I was at 5. So I'm probably looking at November to be out of space, right? So this is really informative data, right? I can go back as far as I have data up to 3 years. So, if you're monitoring this for, your servers for 3 years, you can look at 3 years worth of history to use as your predictive model, meaning that it's much more accurate than maybe 2 weeks, right? But I think the key takeaway was that you can do that for disk, database, and table, but these 3 reports, because of those forecasting algorithms, have to be run on the desktop client. Everything else, though, can be deployed through the deployment wizard at the bottom out to SSRS, including any of those custom reports that you built, right? So you say, oh, take these reports, push them out to this report server. Essentially, you'll have the reports in SSRS that you can subscribe to, edit, etc. So forecast reports are one type. You'll also see a lot of top reports, top server, top query, top database, top application, top table growth. And what we're talking about here, like a top server, for example, show me all the servers today. So which servers have the most alerts, the worst response time, highest CPU, memory, disk, etc. And then I could say, oh, well, let's look at this server. So I can drill into that one and look at charts of response time. This is just from 8 o'clock till now. You can make that bigger, but CPU, memory, disk, and then database overview, right? So I'm using drill down within the top reports to get to more detailed data. The other thing about top, I'll show you another one, top database on that server, do 7 days, top 5. So notice I said top 5, so number of databases in this report, there's only going to be 5. Now, there's different buckets of databases that we're going to be showing. This is going to show me, for example, at the top, there's a lot of databases on this server. Maybe I should have picked a different one. But the top bucket will be which databases are the biggest, right? So these are the top 5 biggest databases. These are the top 5 fastest growing databases. These are the top 5 databases based on read. These are the top 5 databases based on write. These are the top 5 databases based on transaction. These are the top 5 databases based on weight type, right? So that's what a top report is. Top applications, top queries, top servers, top databases. And then there's another style of report. So forecasting is looking at the past to predict the future around space. Top is giving me these breakdowns, top 10 lists, top 20 lists of different categories. The third style of report is just your straight table chart reports, what I call it. So I want to look at CPU. Let's look at prod 1 for the second time we'll do today. Charts, and I have minutes in here, so that's a lot of data, right? So maybe I change that to hours. Charts at the top, table at the bottom, right? So you have that kind of detail that you can play with. But, it's a pretty simple tool. If you guys are interested in playing with the tool, want to download, try, it's pretty simple. If you just go out to the IDERA website, at the very top, you'll see products, SQL Diagnostic Vendor for SQL Server, and you'll hit start for free, and it'll give you a download link. Once you've downloaded, it'll kind of get you in our system. We'll get you an account manager that you'll have direct contact with. If you need help with install, need help with tech support on the trial side, my team handles all that, but get with your account manager and they can make that stuff happen for you. I'm going to check one more time on questions. If there are no questions, we'll go ahead and end it. Okay, guys. Well, hopefully this was a benefit to you, and we look forward to speaking with y'all later. Y'all have a good day.